Hi, I'm Giulio De Leo. I'm professor of biology at Stanford University Hopkins Marine Station and senior fellow of the Institute for the Environment. An area where the potential for win-win solution is very promising is the intersections between health and agriculture. Let me explain you why. Agricultural expansion and intensification is highly needed to feed a growing humanity that will peak to about 10 billion people by the end of the century. Increased food production and security is good for health, no doubt about that. And yet agricultural expansion and intensification will lead to increased use of fertilizer and pesticide, leading to eutrophication, contamination, and also to deforestation, biodiversity loss, and disease spillover. It will also lead to land use changes that facilitate the spread of infectious diseases, such as vector-borne diseases like malaria, and other diseases with an important environmental component in their transmission cycle, such as schistosomiasis. And schistosomiasis is what I want to talk to you about in the next 4 minutes or so. So schistosomiasis is a debilitating parasitic disease of poverty, endemic in more than 70 countries, affecting more than 200 million people, the vast majority children in sub-Saharan Africa. These parasites need 2 hosts to complete its life cycle. The definitive host, typically humans, at least for the 2 most important human schistosome parasites in Africa, and a limited set of freshwater snails, the intermediate host. So the parasite goes from people to freshwater snails and back to people. In the absence of access to clean water, villagers get infected and step into schistosome contaminated water for their daily chores. So what schistosomiasis has to do with agricultural expansion then? Well, agricultural expansion needs water, and water can be provided by the construction of dams. And schistosomiasis is a textbook case of a disease that not only is associated with water, but whose transmission risk increases invariably following the construction of water management infrastructure, typically artificial reservoir for power production or agriculture. Let me show you for a very specific case, the Jama Dam in Senegal. This dam was built in 1986 on the mouth of the Senegal River at the border with Mauritania to support agricultural expansion and prevent saltwater intrusion. It worked incredibly well, but unfortunately, the construction of the dam was immediately followed by what was probably one of the most spectacular outbreaks of schistosomiasis, is clearly documented by several peer-reviewed studies. Why did it happen? Well, the reason of this outbreak is connected to the massive landscape transformation that occurred following the dam, as clearly documented by these 2 Landsat satellite imagery. The first one on the left in 1985 before the dam completions, and the second one in 1999, 13 years later, the dam completions. There is something though you can see from the satellite picture here. And is this guy here, the African river prawn, a native species of Western Africa, the Macrobrachium volmenovi. This prawn is a voracious predator of the snail, and it is also a migratory species requiring brackish water for reproduction, but then swimming upstream for growing up and feeding, among the other things, on the snails that amplify schistosomiasis. Now, the Jama Dam basically was a huge wall that prevented migration, basically extirpating a key species for the top-down biological control of the snails that amplify schistosome parasites, basically creating the perfect storm. But when there is a problem, we also see an opportunity for solution. By using a combination of lab experiment, field studies, and modeling analysis, we showed that restoration of the native river prawns, for instance, through prawn ladder, can reduce disease transmission. And in addition, the combination of medical treatment and prawn restoration is much more effective than medical treatment alone. And there is more. Prawns are also delicious and nutritious food item that were part of the local diet. We just conducted a market analysis showing a great potential for aquaculture production. We built then a commercial scale prawn hatchery and used modeling analysis to show that integrating agriculture with aquaculture, that is growing prawns in dry paddies, a significant transmission site in rural subsistence economies, can increase food security, provide additional source of income for small farmers, restore ecological integrity, and reduce schistosomiasis transmission for what we call the 4 pillars of wealth-generating ecological-based solutions. In conclusion, we believe there are untapped opportunities to leverage natural enemies to fight human diseases. And we also believe it is important to actively pursue integrated solutions that target multiple sustainable development goals at the same time. And with this, I simply want to thank my numerous awesome collaborators and the agencies and foundations that supported this work. Thank you very much.